Alright, so this lesson, our goal is to be able to solve logarithmic equations. And as we're working through this, I want you to think about how do the properties of logs help you solve those logarithmic equations. So we're going to look at two different types of equations. We're going to look at examples where a log equals a log, and then we're going to look at examples where a log equals a number. So these are our guiding questions as we work through this process. The first one is, how can I use the properties of logs to condense the logarithm? How can I use the one-to-one property to write and solve an equation? And then always have I checked for an extraneous solution. And the extraneous solutions that we're really going to deal with is a log cannot be negative. So I can never have a log that is a negative. So if I end up with that as my solution and I plug it back in and I end up with log base 4 of negative 12, I know that that is no solution because I cannot have a negative log. So make sure you write that down and that you remember that the log can never be negative. Alright, so let's go ahead and start with this first example. I have log base 5 of 5x plus 9 equals log base 5 of 6x. So when I look at that, what do I notice right off the bat? Well, I notice that they both have the same log base 5. So since they have the same log base 5, I can use what's called the one-to-one property, which says that if log base b of m is equal to log base b of n, then I can simply say that m is equal to n. So the one-to-one part is that they have the same log base. So if they do, then I can simply say that those values are equivalent. It's similar to when they had the same bases and we were solving the exponential equations. Same idea, except for now that log base is written in the log form. So when I look at number 1, I see that they have the same base. I don't need to condense the logarithm because I don't have log of 2 plus log of 3 or something like that. So I can simply use the one-to-one property to set those two equations equal to each other. So I can basically say that 5x plus 9 equals 6x. And so I've written the equation and now I need to solve it. So let's go ahead and get all of our x's together. So I'm going to subtract 5x from this side and I end up with x equals 9. And then my last question is always, have I checked for extraneous solutions? I want to make sure that when I plug that back in, that x value, I don't get a log that is negative. So when I plug it back in for x, I end up with 54 and 54, which is positive. And so it's not only a check that I solved my equation correctly, but it's also a check because it's not negative. I'm good. That can be my solution. Alright, so go ahead and pause the video, and I'd like you to try number 2 on your own. Make sure you use these rules to make sure that you are setting up your equation correctly. So hopefully you were able to set up the equation and solve that n is negative 7. Now remember, when we're checking for the extraneous solution, the variable can be negative, it's just the log that can't be negative. So hopefully that won't trip you up. But when I look at this and I plugged it back in, that negative 7 in for n, I ended up with 29 and 29. So because that's not negative, I can have n equals negative 7 as a solution. Alright, so go ahead and pause the video and I'd like you to do number 3 on your own as well. Alright, so hopefully for number 3 you were able to realize that once I solved for w equals 6 and plugged it back in, I ended up with log base 9 of negative 12 equals log base 9 of negative 12. So the value makes the equation true, but I can't have a negative log, so I'm going to have to answer no solution. Alright, so number 4 is where we start to get into this question up here of how can I use the properties of logs to condense the logarithm. If you notice, on the left-hand side of all of these equations, I have log base something one time, and then I have something going on in the parentheses, and it equals log base something one time. Whereas number 4, I have a log and a log being added together, and then they equal a log on the other side. So what I need to do is I essentially need to get it down to where it's log equals log. So I'm going to use those properties to condense the log. Alright, so when I look at number 4, log of y plus 5 plus log of 4 equals log of 72, and I know that because there is no base, it's just a that given base of 10. And when I see that I have 2 logs on one side, I need to look at what operation is occurring. So I notice that it's addition. And so when I think back to our properties lesson, addition really means what? Well, it really means multiplication when I put them together because they have those same bases. So I can actually rewrite this log equation as the log of y plus 5 times 4 equals the log of 72. So because these have the same base and they're being added, I can simply rewrite it as a condensed version where I just multiply them. And so now that I have a condensed log equals log and they have the same base, now I can use the one-to-one property to write and solve an equation. So the equation that I'm going to write is actually going to be y plus 5 times 4 equals 72. So I'm able to simply, now that the logs are equal, the one-to-one property says I can just take these values and set them equal to each other. And so to solve, I'm just going to distribute the 4. So 4y plus 20 equals 72, and then I'm going to finish solving it out. And when I finish solving that out, I end up with y equals 13. And I always need to go back and double check. And when I look at this, the only place that there's a variable is right here. So 13 plus 5 is not a negative number, so I'm good. It's going to check out. And I want to highlight, because a lot of students get confused, the reason that I turn this into a condensed version is because I have 2 logs that are being added together. Whereas up here, I had 1 log and then the values being added together were in the parentheses. So I only use those properties when I have a log and a log being added together, not when the 2 numbers that are part of 1 log are being added together. Alright, so let's look at number 5. I have 3 times the log base 7 of 4 equals log base 7 of 4a minus 8. So when I look at it, I do have just a log and a log that are equal to each other. However, I have this 3 times that log out there. So what property told me that I could do something with that 3 times a log? Oh, I remember the power property says I can just go back and make it an exponent. So I can actually rewrite number 5 as log base 7 of 4 to the third equals log base 7 of 4a minus 8. So now that I have log base 7 equals log base 7, I can simply use the one-to-one property to write my equation. 64 equals 4a minus 8. So I got 64 because 4 to the third is 4 times 4, which is 16, times another 4, which is 64. And then the one-to-one property says I can just set those equal to each other. So then I'm going to finish solving. I'm going to add 8 to both sides and then divide by 4. And that gives me a equals 18. So I'm always going to go back and plug it in and make sure that I don't have an extraneous solution. So over here there aren't any variables, so it doesn't matter what a is on this side. So over here I need to plug 18 in for a, so I'll have 4 times 18 minus 8. Well, that's definitely going to be a positive number, so it should be okay. So I'm going to mark off that I checked it. Alright, so for example 6, I'd like you to pause the video and try it on your own to see how you're doing. Alright, so hopefully you were able to figure out that n equals 2. If you got that, you can go ahead and fast forward to the next example. If you didn't, then I'll walk you through my steps now. So what I noticed right off the bat is I had log base 4 minus log base 4 of 68 minus log base 4 of 4. So I had 2 logs on the left side. So I thought about how can I condense them. I noticed it's subtraction, and so subtraction can be condensed into division. So that ended up condensing to log base 4 of 68 divided by 4, which simplified to 17. So that's how I got down here to log base 4 of 17. The right side doesn't condense any because I don't have 2 logs being added. I had the log of 2 numbers being added. So when I got down here to where I had log equals log, I could use the one-to-one property to say that 17 equals 3n plus 11, and I subtracted 11 and divided by 3, and that gave me n equals 2. And then I always want to go back and check for those extraneous situations or solutions. And so on the left-hand side, I don't have any variables, so none of them will be negative logs. And up here, if I plug 2 in for n, I get 6 plus 11, which is a positive number, so it checks out. All right, so number 7 is a little bit tricky, but I think you can do it. So go ahead and pause the video and try it now. All right, so hopefully you were able to recognize that over here I can use the power property, which says that I can take whatever is being multiplied by a log and put it as the exponent. So I was able to condense this into log base 6 of 25 to the 1/2. And then this over here didn't need in condensing, so I just brought it down. And then if you remember, when I take a fraction, when I have a fraction as an exponent, it's using a radical. So it's 25 to the first power, and I'm taking the second root of it, or the square root. So the square root of 25, or if I type into my calculator 25 to the 1/2, I know that's 5. So then I'm able to say log base 6 of 5 equals log base 6 of 23 minus 4w. So using the one-to-one property, I'm able to just set those values equal to each other, and then I subtracted 23 and divided by -4, and I got w equals 4.5. When I plug 4.5 back in, I get a positive value, so I know that that is a solution. All right, go ahead and pause the video, and I'd like you to try number 8 on your own. All right, so for number 8, I was able to get that p equals 7. If you got that, you can go ahead and fast forward. If you didn't, I'll explain it now. So I noticed that this side cannot be condensed. It's already one log of something. And so over here, I noticed that I had two things happening. I had 2 being multiplied by this log, which made me think power rule. And then I also had subtraction of logs with the same base, which made me think division. So I ended up rewriting it like this. So I brought the 2 to the exponent of the 6, and then at the same time, I took this value and divided it by this value using the quotient rule. So when I simplified 6 squared divided by 4, I got 9. And then because of the one-to-one property, I can set those values equal to each other, add 5, divide by 2, and I get p equals 7. And when I plugged 7 back in for p up here, 2 times 7 is 14, minus 5 gives me a positive number. So this is a valid solution. So I want you to look over these examples 1 through 8, and I want you to make sure that you pause the video and write down any questions or points of confusion that you have on any of these solutions, and we can talk about them in class. All right, so for the remaining 2 examples, 9 and 10, for these solving logs when you have a log equals a log, go ahead and pause the video and try these 2 problems on your own. All right, so for number 9, hopefully you were able to get the m equals -9 and m equals 2. And when you go back and check both of those values, they will give you positive logs when you plug -9 and 2 in. And then for number 10, k equals -4 or k equals 4. And when you go back and check them, both of them will be squared, so that will give them a positive value, which would give 2 positive logs. So if you got those answers, go ahead and move on. If you didn't, I'll explain now. So number 9, first of all, I see that I have the same base. So can I condense anything? I have log base 4 of m squared and log base 4 of 18 minus 7m. So they're already condensed. So then how can I use the one-to-one property to write and solve an equation? So I was able to say that m squared is equal to 18 minus 7m. And I saw that it was quadratic, so I set it equal to 0, and I had m squared plus 7m minus 18 equals 0. So what are the factors of 18 that subtract to be 7? Because a is 1. So 9 times -2 gives me -18, and 9 plus -2 gives me positive 7. So when I solve those, I get m equals -9 and m equals 2, which both check. They are not extraneous solutions. They do not give me a negative log. Same thing over here. The first thing I had to do was I had to condense this. So I saw a plus sign, so I knew that was multiplication. So because they're the same bases, that means 2 times k squared, which just gives me 2k squared. And I didn't have to condense anything over here, so I just brought that down. I saw it's quadratic, so I subtracted k squared and got k squared, and I subtracted that 16 to set it equal to 0. And then I saw that it was a difference of squares. Now, I will say if you get to this step and you subtract that k squared and you end up with k squared equals 16, you can do the square root. That's where we can use multiple methods to solve these quadratics. So if I square root 16, I have a positive 4 and a negative 4. All right, so the second type that we're going to look at is when I have a log equals a number. So we're going to have basically the same process, only now we're going to use the properties of logs to condense and isolate the log. And then I'm going to use that exponential form to write the equation, and then always we're going to check for extraneous solutions. So when I look at number 11, this is my log and this is my number. And do I need to condense or isolate the log? I don't. So I don't have two logs doing anything or something being multiplied by the log. So I don't need to condense it. And when I look at it, the log is already isolated. I have log base 2 of a number. So I can't do anything else to get this log value by itself. So now I can use what we talked about earlier in this module, that exponential form. So I'm going to use that 2 to the 6th equals this value in order to write that equation. So what it's going to look like is 2 to the 6th equals x plus 4 because it's log base 2, so 2 is the base, raised to the 6th power is going to equal this value right here. So now I just have a simple math problem to solve. 2 to the 6th is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So the equation I have is 64 equals x minus 4, and then I'm simply just going to add 4 to this side, and I have x equals 68. And then I always want to make sure that that's a value that x can be. So when I plug 68 back in, 68 minus 4 is a positive number. So we are good to go. All right, so let's look at number 12. So I see that I have log base 3 of 4x plus 8. And then from that log, I'm subtracting 7 equals negative 3. So I don't have anything that I need to condense because I don't have two log values and I don't have anything being multiplied in front of the log. However, that log is not isolated because this is the log value and I'm subtracting 7. So just like I would normal algebra, I'm going to move that 7 over to the other side. So I'm going to add 7. And that gives me log base 3 of 4x plus 8 equals 4. So I have condensed and isolated the log. So what equation can I write in exponential form? So log base 3, so it's going to be 3 to the 4th equals 4x plus 8. Now I have a basic equation I just need to solve. And as I solve it, I end up with x equals 18.25. And if I look and make sure that this log would not be negative, 4 times 18.25 plus 8 will give me a positive number. So that checks out. All right, what I'd like you to do now is pause the video. I'd like you to try 13 and 14 on your own. All right, so hopefully for number 13, you were able to get x is 10 as a solution, and then for number 14, x is 20. So if you got both of those values, you can go ahead and fast forward to the final reflection of this lesson. If you didn't get that, I will explain it now. All right, so when I look at number 13, I see that I have two logs that are being added together. So what property can I use to condense that log? Well, I see it's addition, and I know addition goes with multiplication. So I actually rewrote it as the log of 2x times x minus 5. And I went ahead and distributed the 2x, and I got 2x squared minus 10x, and that equals 2. Then I used the exponential form idea that we used to say 10, because if there is no base written in, it's just naturally 10. So 10 to the second is equal to this value. So that's where I got 10 to the second equals 2x minus 10. And I know that 10 to the second is 100, and I see that this is quadratic. So when I think about how do I solve a quadratic equation, well, I have to set it equal to 0. So I ended up subtracting the 100 over here. I factored out a 2 because that's the greatest common factor, and I ended up with x squared minus 5x minus 50. And so the factors of 50 that subtract to be 5, because a is 1, are going to be negative 10 and 5, because negative 10 times 5 is negative 50, and negative 10 plus 5 is going to be negative 5x. So when I solve those out, I end up with this is, if this were 0, x would be 10. If this were 0, x would be negative 5. And then I went back and I checked those values. So if I plug 10 in here, I get 20. and 10 in here, I get 5. Both of those are positive, so they check. But then if I plug negative 5 into here, I get negative 10, and I cannot take the log of a negative number, so that's why I eliminated it. And then looking at 14, I saw that I had a 2 times a log, so I went ahead and put that 2 as the exponent. So I had log of x squared, because I moved that behind the x, minus the log of 4 equals 2. Well, I saw that I had 2 logs, so how can I condense the logs? Well, subtraction is associated with division, so that's the same as the log of x squared over 4 equals 2. And then I used the exponential form where I say the base to that power is equal to this value. So the base is a 10 because there is no other base written in. So 10 to the second is equal to this value. So 10 to the second is 100, but then at the same time, I need to solve for this x squared, so I multiplied by 4. So I really, to get rid of the divided by 4, I multiplied both sides by 4. So 4 times 10 squared gives me 400. So x squared equals 400, so I took the square root of both sides, and I got 20, but I also know that I can multiply negative 20 times negative 20 and get a positive 400. So using that idea back in module 3 when we talked about quadratics, whenever I square root a variable, I always have a positive and a negative version. So I got negative 20 and positive 20. But when I took that negative 20 and plugged it back in, x cannot be, the log can never be negative, so I eliminated it, and I ended up with just 20 as my solution. Go ahead and look over, pause the video, and make sure you write down any questions or points of confusion that you have. Alright, so for 15 and 16, go ahead and pause the video, and I'd like you to try these on your own. Remember to use those guiding questions as you work through it. Alright, so for number 15, hopefully you're able to find that x equals 3. When you solved it out, x equals negative 12 and x equals 3 are solutions to that quadratic. However, when I plug negative 12 back in for this log, I can't have a negative log. So only x equals 3 is my solution. Same thing happened over here. X equals 5 is my only solution. I did end up with x equals negative 2 as a solution to this quadratic, but I can't have a negative log. So when I plugged that in, I was able to eliminate that. So if you got those answers, go ahead and move on. If you didn't, I'll explain it now. So using those same questions that we used for log equals number, how can I use the properties to condense and isolate the log? So first of all, I saw that I had addition here with the same bases, so I was able to turn that into multiplication, and when I distributed that x, I had log base 6 of x squared plus 9x. The 2 just hung out. So then I have log equals number, so I'm going to rewrite it in exponential form. So 6 to the second equals x squared plus 9. 6 squared is 36, and I subtracted it so that I could set the quadratic equal to 0, and the factors of 36 that subtract to be 9 are 12 and negative 3, and when I solve those, negative 12 and positive 3, but again, we eliminated that negative 12. Over here to 16, I also saw addition, so I turned that into multiplication because they're both that common log base. So when I distributed the x, I got x squared minus 3x equals that 1. Now there is no base, so it's an understood 10. So when I have a log equals a number, I'm going to write it in exponential form. So 10 to the first equals x squared minus 3x. 10 to the first is 10, so I subtracted it because this is a quadratic, so to set it equal to 0. And so I have the factors of 10 that subtract to be 3. Well, negative 5 times 2 gives me negative 10, and negative 5 plus 2 gives me negative 3. So I end up with x equals 5, x equals negative 2, and again, we're able to rule out that negative 2 because I can't have a negative log. Alright, so before we end this lesson, I would like you to go ahead in your notes and reflect on the 3 questions we've been going through. What are 3 common errors you think students tend to make when solving log equations? What is your summary of this topic so far? So what are the things that you understand? What are the steps? What are those things? And then how would you rate your understanding of this topic so far on a scale of 0 to 3?